This video is intended to help students understand the classification of matter.
Robin Smith, your ride is out back. Robin Smith, your ride is waiting for you out back.
Your homework today was to define and give an example of each one of these. The last couple days we've been working on using a dichotomous key or a map to classify things. We've done this in science with animals and plants and fish and all sorts of different things like that. You can do this with forms of transportation, cars. We did it in class classifying teachers a certain way. If it's a useful dichotomous key, it will help you classify any version of that plant or of that animal. Well, this is matter. And matter is defined as anything that has mass or takes up space. Not all matter is matter we can see with our naked eye. We can see it with microscopes and things like that. But even the air right now, we know we can feel that hit the back of our hands because it's little particles. That is matter, invisible to the naked eye. Well, matter, anything that has mass or takes up space, is spread into two big groups. One is called pure substances, and one is mixtures. And as we do this, we're going to identify what was the deciding factor of going left or right. If it is a pure substance, it cannot be physically separated. Okay? So we can't physically separate it. That's the first question we ask. Can we physically separate it? Now, can we chemically separate a pure substance? Yes, we can. We'll talk about physical and chemical changes very shortly. Over here, these can be physically separated. Okay? So let's go back over to pure substances, which we can't physically separate or separate by physical means. That is defined into two different groups too, elements and compounds. The question you ask there is there one type of atom present? If yes, it's an element. Same type of atoms. One type of atom present. Now these are things that you would find on the periodic table, because the periodic table is just a list of elements. Therefore, hydrogen, oxygen, lead, plutonium, iodine, all of those are examples of elements. To say air is an element is false, because air is a mixture of different elements combined. Now, if it is a pure substance and can't be physically separated, but there's more than one type of atom there, that would be a compound. Two or more different atoms chemically combined. Different atoms, I'm sorry. Okay? That would be things like water. Water consists of hydrogen and oxygen, H2O. So let's put a couple elements. We have element iron, that's iron Fe. We have oxygen. We have iodine. We have nitrogen. Compounds would be things like water, H2O. It would be things like salts, NaCl. Or what we exhale, CO2. Okay? But again, we can't physically separate those. So there we have elements and compounds. Mixtures, though, can be separated too, physically, but there are two types of mixtures. Homogeneous or homogeneous and heterogeneous. The difference here is if it's a homogeneous mixture, you can only see one thing physically present. So only one thing visible is what I'll put. Okay? And if there's only one thing visible, it's homogeneous. If there's two or more things visibly present, it is heterogeneous. Okay? So back to, if we can physically separate it, we're at mixtures. And if there's only one thing visible, it's homogeneous, then we call that a solution. So a solution is something like salt water, Kool-Aid, which I'm going to misspell here. Those are things we can physically separate. Now think if you were stranded on a desert island. We're going to do the Kool-Aid lab in here and the s'more lab in here. We're going to try to separate Kool-Aid. How are you going to do it? Act like there's salt water there. We know we can't drink salt water, so we have to get the salt and the water separated. So we're going to separate those by physical means. We're going to evaporate the water. We're going to boil it and condense it again and get pure water. We'll talk about that. Back over here, heterogeneous mixtures are things we see two or more things visibly present. So an example would be Italian salad dressing, or there's some other areas where you're not necessarily aware right away that two things are there, but you can using something called the Tyndall effect. Tyndall effect is the scattering of light by small particles. So pretty much this one, suspension, has large particles that will settle. Colloids have very small particles that will scatter light. If I put a flashlight behind it, it'll scatter light, but the particles don't necessarily settle. So an example of a suspension would be Italian salad dressing, or muddy water. You know that if you leave a lake or a pond or a river alone and it's not moving, that water eventually will be clear. The reason it stays murky is something stirring up the water, agitating it. So salad dressing is the same way, where if we leave Italian salad dressing alone, the oil and the water separate. But if we keep shaking them up, they stay suspended. So these are large particles that will settle. Or settle out. Colloid has small particles that do not settle out. They stay dispersed evenly. They don't sink to the bottom or float to the top or anything. So small particles. So you can see two things are there, but you don't necessarily see the boundary of the two things. This has the Tyndall effect. T-Y-N-D-A-L-L. Tyndall effect. Make sure you write that down. Examples of that: if we take a gallon of milk, we put a light to the back of it, a flashlight, the beam doesn't shine directly through the milk. It kind of scatters light and the whole thing glows. That would be the Tyndall effect. If we were shining a flashlight outside, it would shoot a straight beam. But if we were in a foggy area, the fog would kind of glow. It would scatter light. That's the Tyndall effect. So examples would be fog and milk. That is the one that traditionally students have the hardest time with. So again, these are the questions you need to ask yourself. First of all, we need to have this in your notes. You already have the definitions. Tomorrow we'll work on classifying matter. This works for any type of matter. Again, matter. Something that has mass and takes up space. So ask yourselves questions as you go down the line. Can I physically separate it? If yes, I go this way. If no, I go this way. If it's a pure substance, is there one type of atom present, or is there more than one type? If there's one type, element. If there's two or more, compound. Mixtures. Can I see two or more things present? Yes, heterogeneous. No, homogeneous. If it's a homogeneous mixture, it's a solution. With heterogeneous mixtures, do the particles settle out? If yes, it's a suspension. If no, it's a colloid.